All right, we did it. We made it for another show, man. How you doing, buddy?
I'm doing good.
Yeah?
Pretty good. How are you?
Yeah, I'm sleepy. I think a little tired. Not sure I'm going to be able to do it today, Camel. I think it's going to be all you. That's what I think.
Okay.
So anyway, that's kind of how I'm doing. Yeah, I figured if there was any kind of competence that we see today, it would be an illusion. That's what I thought it would be. An illusion.
Okay.
It's demonstrated by that. We're on Camel's machine. You want to show them what we did last time?
Yeah. So last time, we created some test cases for our code, which currently can only add fractions, if I remember correctly, and compare them as well. Right? Yeah. Yes. We can currently add them. And, well, yeah. This is, oops. Wait. So, yeah, that's kind of it.
If you go in the CodeRush menu up at the top there, there's a submenu called Test, and now to the right of that test menu, inside that test menu is the test runner. And you can bring that up, and then you can go hit the Run All button right above the search in the upper left. Right there. Hit that.
And then it runs
And then
all
you
of the
see
test cases.
7 tests pass. So we've got 7 test cases that are passing, which is, you know, generally always good news. And that's what we have. Let's add another test case here. What I want to do on this test case, take a look at this. See this right here? Look what's happening. We've got these variables here. I want to use a refactoring called inline temp. And I'll show you how to use it. Hit the CodeRush key right here. The SuperNumber1, see the variable? It's only used once.
Yes.
Go down and select inline temp. And that'll take that temporary variable and put it right there. Now move the caret over to SuperNumber2. To the right. There you can choose inline temp there too. Okay. Now inline this temp as well.
Okay. Inline temp.
And oh, interesting. It's doing an automatic conversion to decimal. We really don't need that. Let's clear this off. I want to just take out some of these extra parens here. And so now we've got a single line of code that basically adds 1/3 plus 2/3.
Yes.
Right? Now we're looking at, I'm going to drop a marker here. We're looking at this right here, which is a way of putting inside a comment a math formula. So I'm going to copy that to the clipboard. I'm going to paste it down here, but down here I'm going to say, I'm going to spell it out. So we're adding 1/3, so we use the frac right there, plus, and if I type in just a /f here like this, it'll give me another frac.
Ooh.
See there, for creating a fraction. And so I'll type in 2 there, hit enter, 3 there. And now with that on the line, there you go. See the test case?
Oh, yes.
Sweet. So we're saying 1/3 plus 2/3 should be equal to 1. That's what we're looking for in our test. Now we can take that and duplicate that line, and we can create something new down here, right?
Yeah.
We could even turn this whole line into a template if we wanted to. I'll maybe show you templates later. But to do this, we want to come down here. Let's create another one. Can you come up with a fraction add that we want to do a test?
Yeah.
Maybe something that gets me into something bigger. Or I don't know. You can do whatever you want on that. What do you want to do? Don't do this. Start with the super numbers first.
Oh, oops.
Create a test case that adds 2 fractions together and test the result.
Okay. Oops.
400/4.
Yes.
Okay, cool. So 400/4 is 100.
Yeah. And then, oops.
plus 7/9. Okay. So we have to put the answer in the left too as well that we're expecting.
Oh.
So
yes.
maybe we change 7/9 to something that gets to a whole number or gets to a half a number, something like that, like 7/14. What about 7/14?
Okay. Ooh, what about that?
Okay. But then you got to expecting the third, which means you've got to have 3.333 going all the way out. You know what I'm saying?
Sure.
If it's 14th, it's just the same as 1/2. All right, so change that 9 to a 14 out in the comment there. All right, cool. And then change the result to what you're expecting it to be, that's the expected value, which is the first parameter to the left, far left. Scroll far left. It's the first parameter in the R equal. It's what are you looking for it to be? So that should be
this one?
Yeah, that's the one.
So it's 100.5.
Mm-hmm. Good. Save it and run the test method. Good. It passed.
Okay.
Cool. So we know that we can add super numbers together.
Yeah.
Right? We know that seems to be working pretty well. We haven't found a problem yet where that is not working. We could also, let's do another one in here. I'm going to take this original one. I'm going to copy that. And we'll come down here and paste it down here. And now I want to add negative 1/3. Yeah, I'm going to take this here. I want to do negative number. Maybe we'll do this instead. We'll do 1/3 plus a negative 2/3. I should be able to do like that, I think. Okay. And the expected answer of 1/3 plus a negative 2/3 is going to be negative that. Just make sure that's working too. Passed, right? Yeah, passed. Okay, cool. So that's what we worked on last time. We still don't have a UI for bringing this stuff in yet. We have the ability, we support addition.
We do. We don't support anything else though, besides comparison.
Right. We have the ability to see if two numbers are the same, right? Are they equal or not? And we can do we did an op double equals overload. So one of the things that's kind of cool, let's go bring up the KidzCode folder. We'll switch back over to my machine with the PowerPoint. Bring up that slide here. We learned something new last time. And it's essentially about, I guess I'll call it operator overloads for lack of a better overloads. And I'll maybe add in here implicit conversion. All right. And so we've got a new section here. Let's add a new slide. Operator overloads. What do you remember about these, Campbell?
I don't remember what much, but I do remember that it was tricky to figure out the code to.
What did it do?
It basically made it so that C# wouldn't see an operator and think of it as its own code, basically. So
yeah,
we could use it.
It can execute our own code when an operator is applied to our type. Our own types. In other words, we could create something that knew how to add two cookies together, and what its version of add using the plus would maybe meld the ingredients.
Yeah. Which
Instead of creating 2 cookies, it would create a merged one if we wanted to. We could actually make plus do minus and minus do plus.
we could.
If you wanted to really mess with somebody, right? Mess with the developer.
Yeah.
Okay, so
And the one that we converted it from, it was originally doing the intersection, if I no, we had to specify what it was that we wanted it to do, and it was what doing before.
we needed. You're thinking about. I'll show you the code you're thinking about. Let's go over to your machine actually. Excuse me. I think we'll put it over in SuperMath. Get common. We tried union,
Yes.
we tried intersect, none of them were working.
But what was it trying to do at first with the addition symbol?
Hold on. What was it trying to do with the addition symbol? I think, well, let's explore this a second, because get common, we needed that in make fraction proper. We needed to get the factors for both. We needed to find out which were common, and then for each one of those, divide the numerator and the denominator by that common factor to simplify it.
Yes.
So that's what we needed. When you were talking about union and the intersect, we needed that for this call to make the fraction proper. Does that refresh your memory?
Yes.
But do you still have a question, I guess,
No, I don't.
Okay. So that's kind of what we were doing there. And then the other thing we had to do is check to see if the numerator was bigger than the denominator. And if it was, we needed to then change the whole number on the side to make it a proper fraction. Okay?
Yeah.
Let's go look at inside our SuperNumber. Here's our operator overload right here. It's a really interesting syntax. It's a method call, but instead of a method name, it has the keyword operator followed by an operator.
Yeah.
Everything else about this looks like a method call, and it's treated like a method call by C#. When you put 2 super numbers on either side of a plus, it'll call this method.
Oh, yeah.
So it makes the code easy to read. Otherwise, I'd have to have a method called add, and I'd have to be like SuperNumber1 dot add to SuperNumber2. See what I'm saying? I'd have to call an add and pass in SuperNumber2 to put SuperNumber1. But now I can just do a plus, which is cool. We check to see our SuperNumber has 2 different types that it supports. It supports decimals and fractions. So we check to see if it's a decimal. If it is, hey, we just do the plus of the 2 decimal values.
Yeah.
Right? If either one is a decimal, we'll convert them. We'll get you an answer that's a decimal. But otherwise, we get to hear both are fractions. And if they're both fractions and we're doing an add, well, we want to keep it in the fraction form, which means we need to find a new denominator. Right? We find the new denominator by simply multiplying the 2 denominators by each other. It might be a really big number, but that's okay because we're going to call make fraction proper at the end.
Yeah, okay.
Right? So, do we have tests that actually will test the plus, that we get a proper fraction at the end here? I don't think we do. Let's do this. Let's create a test that does 1/6. If I can find the 6. There it is right there. We do 1/6 plus 2/12. And the answer should be, we're expecting it to be 1/3 is what it is. We're expecting it to be. So 1/6 plus 2/12. We're expecting that answer to be a positive 1/3. See this right here? I want to declare this as a constant. I'm going to drop a marker right here. I'm going to make a constant that's a type decimal, and we're going to call this 1/3. And I'm going to do that. Then I'm going to hit escape to come back here. There we go. So 1/6 plus another 1/6 essentially is 2/6, which should get us 1/3. So if this comes back Oh, you know what though? This is going to do implicit conversion, which is not the test I really want it to do. It's going to see, well, this is a decimal, so let's actually take 1 divided by 6 and return it. That's going to be, that's not going to work. What I need, and I just thought of something. I think we have a bug in here. What I need is instead an R is true. I need an insert is true, and I need it to do this. The real check I need to do is a new SuperNumber of 1/3, and is it equal? I need to do that. Is that true? Maybe not. That I think also doesn't do the test. I'm sorry, Campbell. I was like, I'm just thinking about what's going on behind the scenes, and it looks like we have a good test, but I don't. This is, I think, the best way to do this. The truest way to do this to see if this is working correctly is we want to say R equal, and I want to say my expected number is going to be 1 here, and then I want to check here what is the numerator. Is the numerator 1? And then I want to come down here, and is the denominator that? And then I want to maybe also compare this to the whole number. Okay, like that. That's what I think I want to do. Okay, yeah. Because then that just flat out is checking to see, did, this is, and I'll put a comment here that we are testing that it simplifies after the add. Does that make sense, Campbell?
Yeah. Yes.
Okay. So we're going to make sure we have 1/3 as the result of these two things right there. Okay? Yeah. I love that when we do the plus here, we are returning, if we go back to SuperNumber and our operator overload, see, it returns a SuperNumber.
Oh, yeah.
Right? So we're figuring out the new SuperNumber and returning it. So that's cool. We never change these as part of the add. So these could be two different variables, right? For example, I could come in here, create a new SuperNumber, call it 1/6, like this, and set it equal to this. Right? And 1/6 will always stay the same. You can create a different SuperNumber called 2/12, like that.
Yeah.
Right? And so I'm just adding the two together. And so test and simplifies the add. All right, let's do a test here. Now I realized I think we might have a bug, and while I was doing all this, I was thinking, oh, here's how we could test to see if we have a bug. All right, that passed. So that test passed. Cool. I love this. So we're creating a lot of test cases, right? The more test cases we have in general, the better. The better the situation is. I want to do. Let's see if I can remember how to get to the bug. The problem is that I thought we might have is when we convert, it's in our value property. Value. If type is fraction, we say, well, the value field is equal to whole number plus numerator minus divided by denominator. All right, I think I can figure out the test. I think the bug is there. So we're going to call this, we're creating a test method. We're going to call it check value conversion. Like that. So we're going to create a new SuperNumber. I think we created a template for that. I'm going to make it be -1 and 1/2. Okay, like that. And let's declare a new local variable for it. Let's call it SupNum. Set it equal to that. And then Then I want to check to see if these two are equal. Well, that would be negative 1.5, right? And my SuperNumber. I think this is going to fail. Yeah, it expected it, but it got something completely else is what it got. We set a breakpoint here. We could also do this too. If we didn't notice how down here it's just saying, hey, you got a SuperNumber. I could come down here and just say dot value like that, and now I'll get a better thing down here. Watch this. If I come in and run it one more time, it'll still be wrong,
but it will tell you what's wrong.
It gave me negative 0.5 instead of negative 1.5. See that?
Yeah.
All right. So here's the problem. The problem is this will work if I make this a negative 1. But that's not really how we think of negative numbers, right? We think we just need the sign here and we're good. See what I'm saying?
Uh-huh.
So what we can do to make this work is when we create the new SuperNumber, we've got a whole number and we got a numerator. I think we do this. We call math.sign.
What does that do?
It returns a negative 1 or a 1 or a 0. So if this is a 0, math.sign will be a 0. If it's a positive number, math.sign will be a 1. And if it's a negative number, math.sign will be a negative number.
Okay.
But I also want to make sure that, so, you know, in case somebody does a negative number, passes in a negative 1 and a negative 1 in both these places, I want to make sure that we come in and we say math.abs here. Oops. Math.abs. Remember what ABS does?
I think so. But what?
ABS stands for what? Do you remember?
No, I don't.
Oh, it stands for absolute value.
Oh, which just makes it positive.
Makes it positive no matter what. So I'm going to make the numerator positive no matter what, and make the sign, take the sign of the whole number. So if this comes in as a negative number, then my numerator will be also negative, which means that other code will work. The other code in the value piece, this line of code right here, which says, hey, it's equal to the whole number times or plus the numerator divided by the denominator. So if it's negative, both this and this, those two numbers will be negative. And if it's positive, both of these will be positive. You okay?
Yeah.
You look like I feel right now, man.
No.
All right. So
I
now,
don't know how you feel, but
let's go try. You don't know how I feel, is that what you said?
yeah, but I feel
like this,
don't feel
man.
like what you told me.
All right.
Huh.
Oh, you know
it's
why?
expecting,
We need to do that so that the
Okay.
types are the same. So we do this and we run it. This should now work.
Yeah.
Okay. Now, also, we can take this away now and it should still work because that implicit conversion is going to happen. Right? It's going to implicitly convert this to a decimal and see it still works, still passes. Now, we just made a change to like, what was it? SuperNumber, which is a pretty low level class, right? Looks like we don't need value as string at all. Not using that anywhere. Okay. Whoops. Wait, what's happening with value as string? Are we using it? Looks like we're not using it. I'll delete it.
You accidentally deleted decimal though.
Oh, thanks. That's probably why I was like, wait, why is that gone? I thought I still had it. Whenever we make a change to something low level, it's a really good idea to rerun all the test cases.
Why?
Because we could have broken something.
I thought, but if this one is low level, then it doesn't have any descendants or many descendants at that.
Right, but it's a low level core class that everybody depends upon.
Oh.
Right? And we just made a change to it. So any tests that deal with super numbers, we should run again. So I'm going to hit this button to run them all again, make sure we still got 8 passing.
Oh. We got 7 not passing.
Really interesting.
They all seem like what we saw before, where it's like it expected this, but was that exact same thing. So.
Yeah, let's try undoing that change. And see if those other ones all come back. Is that because I'm really like kind of like, wait, what? Let's change this to this. Oh, I know why. They're all where the whole number is 0.
Oh.
Remember I told you that math.sign of the whole number would be 0? So what we need to do is we need to create a new a multiplier variable right here. Multiplier. And we set it to 1 by default. And then I want to check to see, hey, if whole number is not equal to 0, then I want to say my multiplier is equal to what?
Oh, wait.
I'm going to put my multiplier right here. That's what it is right there. Math.sign a whole number. Okay, so I'm conditionally, so if whole number is 0, this will just stay a 1. But if whole number is not 0, we're going to change it. All right? Do you understand now why it's a good reason to run all test cases? Okay, so now we've saved this change. Let's go in here. Let's run all the test cases again. Still have one problem here. Look at this. See that? Whole number 0, but this guy's negative. I have to support this as well. Do you understand why this is problematic?
Oh, yeah. Huh.
Do you understand why it's problematic?
Yes, I think so.
Tell me about it.
Because it will make the multiplier a negative number, and then try to
Well, if it makes the multiplier a negative number, this will work. I want this to be a negative number, the multiplier, because it's a negative 2/3. I can't specify it here because it's 0. We're almost done. The problem is this. Look, if the whole number is equal to 0, let's put an else clause right here. If the whole number is equal to 0, right, then I need my multiplier to be my sign of something other than the whole number. What's it going to be the sign of?
Oh, the numerator.
That's it. That now should fix it. Okay? Now do you see why it's a good idea to run test cases?
Yes.
Every time. All right, let's go try it again.
Yeah.
Look at that. Okay?
Okay.
Cool. All right, not bad. Okay, we've got, so here's, we were talking about implicit conversion. This is our implicit conversion right here that converts from a super number to a decimal. And we're just calling back d dot value. We could also create something that returns a Boolean, true or false, that basically says, hey, value is not equal to 0. Right? In other words, we could now do a test that says, hey, if right, and that now means it's not 0. If we wanted to. That's a Boolean now. This will convert to a Boolean implicitly, meaning without anything explicit, without me telling it, you now have to be a Boolean. And if it's ever asked to become a Boolean, it'll just check to see if the value is not 0. Does that make sense?
Yes.
Yeah. So that's implicit conversion. We can do implicit conversion to any type we want. Sometimes it's useful. This is my comparison operator overload. To do this took a lot of code. Right? That's why we use the code-rich template to do that. Right? Build all of this. And then we have that operator plus. There it is right there. That's the operator overload. And this code here is all just pretty much local. It's just the declaration that makes it tricky. So I think we want to do maybe multiplication next. Or subtraction next? I don't know. What do you want to do next?
Yeah, I think multiplication.
Okay, so type in a star right there.
Yes.
And go down here and try to see if you can figure out the code. It's going to be somewhat similar structurally to at least the first part of this piece above. We're going to need to check to see, hey, is anything a decimal? And if it is, we're going to return a new super number with the right answer. And then otherwise, we're going to have to do some code down here. Do you want to just copy this?
I did.
Okay, go ahead. Good, you can do that. Your selection increased if you want to get it?
I already did. I copied it.
Okay.
I think, yeah.
Oh, just the top part you copied.
Oops.
Which we can do, but that's all right. We can do it a piece at a time if you want.
Huh? Wait, what?
We
Sorry.
can do it a piece at a time if you want, or you can just copy the whole thing. Don't forget, selection increases a fast way when you've got your hands on the keyboard to copy that, to get that selected before you copy it. And here, selection increase is a fast way to get all of this so you can replace it. All right, what's line 141 changed to?
This becomes an asterisk.
Right, agreed. Okay.
And then this also becomes an asterisk. And
Now, what do we do? What do we generally do when we multiply? If we have an improper fraction, or I'm sorry, if we have a proper fraction like 1 1/3.
we multiply the top and then we multiply the bottom.
Right, but if I have 1 1/3, the 1 isn't really clear where that is in terms of, is it the top, you know, is it, you know, where, what do I do? If I
Well,
have
you
2
multiply
1/3.
that times the final fraction that you get. So if you have 1 1/3 plus 3 and 2/3, then you would have
I mean times.
times.
Yeah.
Sorry. Then you would end up getting so 2 on the top, and then on the bottom for the denominator, you would get 9, and then you would multiply. Well, 1 is you wouldn't multiply that times it. You wouldn't multiply that by the fraction because that is just 1. It won't affect it. But then you take the 3, I think I said, and then you would multiply that times the final fraction.
I'm not sure if that's correct. I'm not sure if that's correct, if that'll work or not. I do know one thing that will work, and that if I have 4 1/3, and I convert that to an improper fraction where there's the 4 is gone, and I bring that, convert that to 13/3, 13/3, then everything becomes super easy. I don't have to do any final step at the end where I multiply. Here, I'll show you what I'm talking about. Let me see if I can get my whiteboard working here. I think I'm going to start up my tablet, and we'll take a look at that. Let's see. Work area. Looks like I need to unplug and replug it in. Is that going to see it? No?
Wait, we're on the wrong screen. I believe.
Wait, there we go. I just to push it in a little more. Okay, we'll switch over to my screen on this. Let's see. Check out my work area. Work area looks good. Okay, so we'll take a look at this. Is what I think is not going to. I think it's more complex, is what I think it is. Let me create a new empty page here. All right. So if we have 3 1/3, and we're multiplying that by, let's do 7 1/7. Okay, like that. Like that. Well,
Yeah.
for me, what I would do is this. What I call this the easy way. I'd say 3 times 3 is 9, plus 1 is 10, so I have 10/3. Times 49 plus 1, which is 50/7. That's equal to 10 times 50 all over 3 times 7, which is equal to 500 over 21. Does that make sense?
Yes.
And I'd say like, okay, that's how I do it quickly, right? But if I keep the 3 here and the 7 here, I'm not so sure about that, right? Because it's not like the same as 1/3 times, I don't think it is. I don't know, we can try it. Oh no, I guess it is. It's going to be 3 times 7, because, right, commutative property multiplication allows me to swap the order of these things, right? And times 1/3 times 1/7. So what we have to do is we are going to multiply, I think this is what you said, and so yeah, you are right. I was thinking there was going to be kind of a plus operation on this second piece here, because I was thinking 7 plus 1/7, but it really does seem to be just that. It's just we're going to take the whole numbers and we'll multiply them. That's what I think you said. And then we're going to take the fractions and multiply them.
Yeah.
And then we're going to call make proper fraction on it.
Yes.
Okay. All right. Boom. That's it. Let's check for negative numbers. If it's a negative number, if one of these is negative, the whole number will be negative, right?
Yes.
Also, the numerator will be negative as well. We are now guaranteeing that those are in sync. Does that make sense?
Yeah.
So now if 1 is negative, okay, it looks like we got a problem though. Here's the problem. If this is negative, then what's going to happen is this is going to be negative here, and that's going to be negative, which is going to get me a positive, which I really want only a negative. I need the sign to be only applied once. Do you understand what I'm saying?
Yeah.
So I think for multiplication we do this. We figure out the end result of what the sign is. We multiply everything, the absolute values of everything, or we multiply everything, take its absolute value, then apply the sign at the end. Right? That's what I think we do. All right, let's do, I think for this, we're going to need to also know, the sign of, we're going to need a property of the SuperNumber that tells you its sign. Does that make sense what I'm saying? We need a property to say, are you positive or negative? So let's do that. Let's do a couple things in here. Let's create, first of all, a property that returns whether it's positive or negative. It's just a read-only property, and it's going to be an int. So to get a read-only int property, type in R for read-only property, and then I, and then do a comma, because we don't need any backing store or anything like that. A comma means smaller. And call this sign. Hit enter. And then inside where it's got that throw right there, that throw statement, just do a selection increase on that, or shift end to get that. And yeah, replace it. And we're going to return what? What will we return to reveal the sign of this?
Well, we would need to set sign.
We need a return statement if we're going to return something. So don't forget that. Start with the return statement. And there's things you need to know. There's a math.sign call.
Yes. Oops.
What are you going to do the math.sign of?
What's it called? The, what is it called again?
I'm not sure what you're trying to think of.
The thing that goes in here. I know what it is, but I'm not sure what it's called.
It's one of the properties of SuperNumber.
Oh, wait. Yes. The whole number, right? Oh, wait.
There you go. You're getting closer.
No, it's the numerator.
Okay. Still getting closer.
And then... Oops.
Hit shift space. There you go. So that's not bad. Okay? That's not bad. We've got a couple potential problems though. What happens if the type is of type decimal? What are we going to return here? If it's a decimal type.
Oh. Math.sign value.
Nice. Good job. Math.sign of value. Good. What happens if numerator is 0? What happens if numerator is 0 and whole number is equal to 0? What are we going to return?
Denominator, right? Math.sign.
No. Because think about it. The whole number is 0 and the numerator is 0. What is the value going to be?
Oh. 0 then.
So we're just going to return 0 here. Right? If both of those are 0, right? Now, what happens if numerator is 0?
It's just numerator is 0, then we return whole number.
No,
Math.sign.
Yes.
Math.sign, parentheses, whole number.
Right. Good. That, I believe, is what sign looks like. That feels to me like that's going to work. Right there. We can add some test cases. Okay, we might come in here and do just a real quick test case here where we're going to come in here and say, new test case, test sign, like this. I'm going to type in NSN, that's that template for creating these. Let's make it a negative 1 2/3 like this. We're going to create a new SuperNumber. SN like that is what I'll call it. And semicolon out there. Looks like Surly Dev's out there. He's Surly. And now we're going to say assert equal. The value is going to be -1. And we're going to say sn.sign. Like that.
Okay.
Okay, makes sense?
Yes.
That's one. And just like we did before, we could come in here. I didn't modify this. This should be a -1.5 right there. Like that. Okay. Yeah, we can do that for now. I can copy that. Let's go do a positive number as well. Well, let's do this. Let's do a test with a negative number here. Okay, so this is now a -1/2. Like that. And oops, this right here. Oh, hold on. Did I make them I jumped into the wrong piece right here. Okay, -1/2 is there. And now I want to check to see if the sign of -1/2 is also -1. Like that. With me so far?
Yes.
I think there's a negative. I think there's some kind of indicator for a negative sign. I don't know if it's that. No, I didn't like that. Forget what it is, but I think there's one that gives me a smaller minus sign up there. Let's copy that. Let's do another one. We want to test kind of for all these different conditions, right? So here's just a 0, right? And this should be 0, and it should be this dot sign. And I forgot to do it up here as well. That dot sign. We need also we need one with a 0 in it. So we need something like where are my sign tests? We need something like here, call this 1, like that. And the sign there. And we need one that is a positive here, which is going to be, we can make it 1, half like that, and this is going to be 1/2. And this one's also, we want it to come back as a positive number, so we got a positive there, 0. We don't have a negative number followed by a 0, so let's do that and get this to a -1. This sign should be what here? Wait, if I change the SuperNumber to that, what should this be? What are we expecting -1 sign to be?
The -1 sign to be negative. Just
-1,
I guess.
right? Okay, good. And then I feel like there's one more that I missed. I guess that's maybe good enough for now. All right, so let's run that. Run that test.
Ah, 1 failed. It expected 1 but was 0.
All right, that's a great one. I didn't expect that. Let's go take a look and see if we can find where the problem is there. So in that scenario, numerator is, I don't understand why that one's failing. This is the numerator. That's the whole number. All right, let's set a breakpoint here and step into it. All right, so now we're going to go over where sign is. Here's sign right here. Set a breakpoint in there. Let's run until we get to it. Hitting F10. Why don't you hit F10 and we'll look at each one right here. So is type decimal? No. Well, that's good. That's what we're expecting. Are they both 0? No. Numerator is true. What's whole number? Hover the mouse over whole number.
Okay.
Oh, I think I know what the problem is, Campbell.
What?
We're bringing back a 1. Well, maybe not. That should totally match and be okay. Expected a 1. View the details. Oh wait, actual is 0. How did sign return 0? Wait, we just saw it, I thought we just saw it returning a 1, sign of whole number. Oh, look. See that?
Oh.
That's the problem. Okay, good. That's why we've got test cases, right? So back to the test runner, run them all.
Woo.
9 out of 9 pass. All right, good.
That's great.
And we're getting better. And we've got it. We've got now. Do we do this? We haven't done the math here yet for multiplication. We haven't finished it. We did it for this one. Shirley says Gesundheit.
Shirley is in the house.
So you want to write this code?
Sure.
Oh wait, did you do it already or no? You've got super whole number. You've got whole number times.
I don't think it's done yet.
Did you make this change? It looks like you made that change.
I did. I made that change.
I don't know why that happens on this show. I don't know why that happens on this show. All right, back over to your. Okay, so you changed that to a times.
Yes, and an asterisk.
All right, fine. That's my times. Okay.
Yes.
Now you're going to take care of figuring out what the new denominator and new numerator are when I multiply together SuperNumber 1 and SuperNumber 2. So what do you have for? Let's look at line 148. Right, your new denominator. Are you done?
I don't think I am.
Do you not think you are by the way I asked the question? Are you done? Or do you think there's something else you need to do?
I think there is something else that I need to do because this
All right, well,
doesn't
hold on.
quite
Let's-
make sense as it is, but I don't know what.
Let's
it is.
ground ourselves visually here, right? Look, if we're not sure, let's always go to a visual. So switch back over to my machine here, right? Let's get to a new, let me duplicate this. Let's create a new slide here. And layout, do I just have an empty blank? That's what I want right there. Okay, so we're basically now, we've got a numerator, we'll call it A, and we've got a denominator, call it B. Okay? Yes. We're multiplying that by another one, which we'll call this one C over D. Now we need to figure out the new numerator. You've got code on line 148 that takes your, oh, it's the denominator. That's the number on the bottom, right? Sorry, I was thinking it was the numerator. You've got code on line 148 that multiplies those two together. Well, we know, what does this equal? When I'm multiplying fractions, what's the number on top here?
The number on top is called the numerator, and it's A times C.
Right, AC in this case. And what's the number on the bottom?
The number on the bottom is BD.
Okay, so it's BD. All right, so let's go back and look at your code. That's just the simple, that's all it is. There's nothing else once I multiply that I have to do afterwards. Oh. Right? I just multiplied these two denominators. I multiplied those two right there. Let's go back and switch over. So what's code look like?
Okay. The code looks like it's just that, right?
Okay, you mean line 148. Okay, good. What's going on in line 149? Well, let me ask you this. Does line 149 look like this right here? B times D.
It does not.
Okay, well, let's make it look like it. Oh, wait, it's the numerator. It needs to look like A times C.
Yes, so. It does now. At first it was like this, but now it's like this. And that was, I think, all that had to be done.
Well, look at the denominator. New denominator is equal to denominator of SuperNumber 1 times SuperNumber 2's denominator.
Yeah.
But the numerator is equal to the SuperNumber 1's numerator times SuperNumber 2's denominator times SuperNumber 2's numerator times SuperNumber 1's denominator. You've got like A, B, C, D kind of multiplied all together. You've got 4 terms here. I understand you're trying to keep with the structure you got before, but the structure you got before was for adding. With adding, we needed to find a common, or we needed to do other things that were different. That's why this structure doesn't match. So you have to recognize, look, you know what? I'm going to violate the structure that I was given to get something that actually works, right? So that follows the logic. So to get a new numerator, the logic says we multiply.
So we have on top.
Hit enter there to take it.
Dot. Numerator? Yeah. Numerator here. And this times SuperNumber 2 numerator. And then that over? Wait. Yeah, over.
What do you mean over? You got my eyes. I'm going like, wait, what? Numerator? The numerator's already over everything. Right, the numerator is the number that comes on top. Look at what we're doing with that numerator. We're passing it in to create a new one. See what's happening down here in line 151?
Yeah.
Yeah, you're doing too much work, my friend. I want to back you up. Back that up. Look. Hold on, I gotta get the mouse over. Let me bring the mouse over. Take a look. See this line right here?
Yeah.
When we pass in new numerator here, it's already going to be over the denominator.
Oh, oops.
See what I'm saying? It's all you need to do. The math is simpler than this. Now, here's the thing though. Remember we said we were going to have problems with the signing of these when we had 2 negatives? When we had a negative number, that the negative number of the whole number and the denominator?
No.
You don't remember that? Let me show you. Let's switch over. That's okay. Don't worry about that. Take a look right over here. Remember when I said this is a negative 7 and 1/7? Internally, this was going to be a negative 7 whole number, and internally, this was going to be a negative 1. numerator. They were both going to be negatives, which means if we multiply this times this, we get a positive when we really just want a single negative.
What? Can you say that again?
Yeah, we have to go back and look at the code to understand this. Let's go back and look at the code. So in the code, in our constructor, and it's maybe with the, the problem is in the way we're building this, but we have some code that goes like this. See this?
Yeah.
That's the code we added that I'm talking about. If we pass in a negative number here or a negative number here, right? Well, if we pass a negative number here, the whole number is negative. If this is 0, we can pass in a negative number here and get a negative fraction.
Yeah.
Okay. In order to do that, in order to make all the other code work, we need our numerator to match the sign of our whole number. And to do that, we added this code. So if the whole number was negative, we'd make sure no matter what that the numerator was also negative. Because it doesn't make sense. Generally, the way we write fractions, let's switch back over to my machine. It doesn't make sense to write a fraction like this, where I have, 7 and negative 1/3. Do you see what I'm saying?
Yeah.
We generally don't write fractions like that. We generally write, if we wanted to do something like that, we would say it's equal to 6 and 2/3. Do you see that? It's like, we don't write it like this. Does that make sense?
Yes.
Okay. So if this comes in positive, this is going to be positive. We just made that code do that. Does that make sense?
Yeah.
Okay. Now the problem we have though is in here in multiplication. Because if we're going to store, if this comes in negative, we make this numerator negative. Do you see what I'm saying?
Yeah.
So I have one negative number, but I've got two things I might be multiplying by each other that will turn positive, because a negative times a negative
is a positive.
Yeah, it is. So what I need to do in the multiplication, in order to get around this, is to, let's go find our multiplication, right? What I need is to get all of these have got to be, we got to go to, I think we got to do this. We got to do math absolute on all of these, and then multiply the new sign by the end result, whatever the end result is. What'd you say?
We're on the wrong machine.
Oh, we're on the wrong machine. Sorry. That's what I think we have to do. So we're going to take math absolutes of all of these, and then we're going to figure out the new sign. So I'm going to create a new int here, call it new sign. Okay, like this. We'll say it's equal to, I'm not sure they'll say anything on this. Then we want to do this. We want to say, hey, if SuperNumber1 dot sign equals SuperNumber2 dot sign,
Yeah.
if they're both equal, then the new sign is going to be a positive 1. Because a negative times a negative, right? If they're both negative 1, then a negative times a negative is what?
A positive.
And if they're both positive, a positive times a positive is what?
It's a positive.
Okay. And I think then we can say else new sign is equal to negative 1.
Yeah.
Okay. Is what I think we can do. Even if there were 0, we could still say if one of these was 0, we could still say the new sign is negative 1, because we're just going to use this to multiply two numbers. This one times that one, and this one times that one. Does that make sense?
Yes.
We also might, a new denominator will always be positive. We also might do one more minor change, and that is in our constructor, we might insist that the denominator is always positive. That nobody can ever pass in that. We could even do a check that throws an exception that says, hey, if a denominator is less than 0, then we can throw a new exception that says, hey, denominator must always be positive. Denominator must always be positive. Like this. I don't need to pass in. Oh yeah, let's do this. I like interpolated strings better than string.format calls. So we can do that, and we can say even, we could pass in the denominator right here using the interpolated string. Okay. We can also do this. We could say, no, I think I'm okay. I was going to do another error to say, well, we could do this. If the sign of the whole number times the sign of the numerator was a negative number, then that would mean one of those is positive and one is negative.
Yeah.
And that would be an error as well. So we can do that. We can say math.sign of whole number times, and I'm just going to duplicate that, math.sign of numerator, if one multiplied by the other is equal to a negative 1, then we got to throw in an exception that says something like this: whole number and numerator. And so what I'm going to do here is I'm going to put that in there, and I'm going to grab whole number and put it in there as well in the error message. So we'll say whole number and pass it in. So we'll see what the value is on. Must always have the same signs.
Hey, can I ask a question?
Yeah.
Why are there 2 equal signs up there and not 1?
Because that we are checking to see if those two are equal. If we were setting them equal to each other, then it would just be 1.
Don't tell her the secrets of programming.
Now I'm just
She's going to understand everything.
Wait,
So when you're checking, you do a double and it checks it, and then you take one away to set.
yes.
Got it.
Can you film it?
No, she knows
We're not doing
everything.
it right now when you're here.
Okay. All right.
Okay, now, can you guys just refactor this stuff? Because it's seems a little
Sketchy?
Sketchy.
How'd your show goes, guys? Is it good?
Yeah, now we're coming on yours. Hi, we're crashing. Hi,
Crashing
here
us
we
out.
are. Whoop whoop.
Surly's out there.
Hi, Surly.
Karen says hi.
I can't even.
Something's going wrong with my head.
There we go.
Wait, this show looks much better with just a little bit of addition.
Little bit of color. Surly says, hi Karen, how are you?
I'm perfect in every way, Surly Dev.
Perfect in every way. She is. Okay, cool. So now what I want to do, so we've done that, now back over to math. Did we figure that out? Did we get that all right?
I think we did.
The multiplication, did I multiply it? Yes, I'm multiplying it. See that?
Yes.
So we're just basically checking to see. So here's the thing. Notice if one of these is 0, if one of these two numbers is 0, let's see. If whole number is 0, and the numerator, I want to change the order of these because numerator comes before denominator. Just so, I think that makes that code easier to read there if I change that order. I'll do the same thing here. So we'll always kind of work with these in the triplets of 3. Okay, so now we need some test cases for this operator multiplication. You want to take a stab at that?
Sure.
You can also say no. It's okay to say no if you don't want to.
I'm just not quite sure how at the moment.
To create a test case?
Yes. Or no, I know how to create a test case.
Well, give me that. Give me close, man. We're on a team here.
Does this work? Or?
No, you have to be in the test unit for it to work, and you have to be outside of a method. You have to be in the class. So let's call it test multiplication. Look at this. You did like half the work already. We need to create some super numbers. One of the things that's just occurring to me though, see this? See these?
Yeah.
These are kind of useful. I'm going to cut them from here, and I'm going to move them up into the class. as things that the class owns. They're essentially like constants. See what I'm saying?
Yeah.
We can do 1/6 times 2 12ths right now with these two pieces. We don't have to redeclare them is kind of what I'm saying. 1/6 times 2 12ths is what?
1/6 times 2 12ths is it's 2 70ths.
Close.
2/7. Oh wait, no, it's 1/35.
6 times 12 is
Right. Wait, am I?
your numerator? Do you want to do it? You want to see it visually on
72s.
What'd you say?
So it's 1/36.
I see. Got it. 1/36. Cool. So we're going to come down here and on our first test that we create in the method you just built for us here, we're going to say, we're going to do this. Type in AE for R equal.
AE.
Yeah. Let's type in NSN to create a new SuperNumber.
Oops. Will that still work?
Try it.
Yes.
And then you're going to say a 0 here, right? You said it was 1/36th, right?
Yes.
1/36. Good. Hit enter. And then we're going to turn actual into the two pieces above, where we're going to say 1/6 times 2 12ths.
12s.
See it? This 0 and 1/36, that's 0 I want to get rid of right there. Okay, so 1/36. You want to hit run on test method, test multiplication, see if it works? On the icon, right? So it's not too hard. It's just a AE for assert R equal.
It passed.
Nice.
In 1.98 seconds.
So we've got that. We also have a 0 somewhere in here we created. It'd be really handy to throw a few tests with 0 in there. Where's that 0 I created? Here we go. Look at all these. These are all beautiful numbers that we should grab up here. This is -1. And all right. So let's call this, let's give these better names. We're going to call this -1 2/3, -1 2/3. I'm going to take that and that. Just drop a marker here. Let's go up to the top. We'll start pasting them in. So we just got, all this is doing is just giving us some numbers that we can reuse in different places. So we can, we've got some good fractions and different numbers that we can use for testing. -1 and this one right here, like that. And now we can come down here to our multiplication piece. Where's our multiplication? There it is right there. Can you get me another one? Let's do an assert equal of 0. So just type in 0 here. We're expecting a value to be 0, and I'm going to multiply something by 0. No, not, I'm sorry, z with a ZERO, the 0 that we added up above. So we're going to compare 0 above with, and then go ahead and hit enter, with, let's say, 2 12ths times 0. 2 12ths times 0. Right. And let's run that. Failed. I'm able to create an instance of it. Whole number and numerator must always be the same sign. See that exception? That's awesome news. And maybe that's, yeah. So the problem is here. Well, you know what? We're going to allow this error. I think it's not okay. If this is positive and that's negative, that's when we should throw the error. In other words, if I do this and that, now I've got a problem. You see what I'm saying?
Yeah.
But allowing this one, I think, is okay, because a lot of people will think this way. I want to be to -1 2/3.
Yes.
Okay, so let's fix the error. So in that case, we don't fix the test, we fix the throwing of the exception. So it's not this is the test we want. We want to basically say, hey, look, if the whole number is equal to 1 and the sign of the numerator is equal to -1, then we want to have an exception. It's not that they always have to have the same signs, but whole number, make the whole number negative instead of the numerator. The whole number negative instead of the numerator. That's going to be our new error. The cool thing about this error, though, is it tells the programmer, the errors tell the programmer how to fix the problem.
Yeah.
Right? Because we see the error down here. Okay? Let's try running all the test cases again. Good. Everything passes. Okay? That's cool because we could also come in here.
But wait, why did it work?
What?
Why did that work?
Because I changed this. It used to just check to see if they were the same sign. Now it checks only specifically if the sign of the whole number is 1 and the sign of the numerator is -1. In our test, where we were failing, we decided to allow specifying negatives by only changing the sign of the whole number.
Yeah.
Or alternatively this. If we want to get the error to come up, we do this, we'll call this a bad -1 2/3. Like that. And this will generate it. See what's going on there? This is the way I said we never really write numbers like this, right? See what I'm saying? So that one, now if we try to run all the test cases, they should all fail because it can't even instantiate the test class, right? See, it can't create them. And they're all saying, make the whole number negative instead of the numerator. See that error message? That's the one we see now. Okay, so we can get rid of that. Although we could take that and create a test. One of the things we can do is we can say test bad data like this, create this one, and I think there's a way, and I forget how to do this, where we can specify that we're expecting an exception. I forget totally how to do this. Expected exception. There it is.
Sorry.
No worries. Expected exception, like that. And then I can specify the exception type. Well, the exception we throw is a regular exception, but these really, I think there's a, is it a, whoops, hold on. I think there's a parameter exception, I think. Is that right? It is, what is it? Invalid. Bunch of invalid exceptions. What kind of exceptions do I have here? Exceptions. We can specify argument exception. That's what I wanted. So now we're basically saying the argument is bad. Okay, like that. So now we can come over here and say, hey, we're expecting an argument exception. What's the other parameter? Properties, some other properties. I think we can just do this. And now what'll happen is we should throw the exception. We throw the exception, the test case should pass. I think I need to specify a type of right here. That's what it wants to know. So basically I'm saying my test method is expecting to throw an exception. Let's run this. Look, it passes. Isn't that so cool?
Yeah.
So before where this would fail, so now we can test to make sure that the problem is the way it, the problem is the problem that we're preventing against, we still are preventing against it. So that's another way of doing it. Okay? All right.
Yes.
What's our time right now? 11:23. Okay, so we've gotten multiplication. And multiplication, we don't have a lot of test cases on multiplication, to be fair, right? We kind of want to do a few more of these, I think. We need some negative numbers times other things. Let me drop a marker and see what we got up here. I got -1 2/3. I have that 1 2/3 times -1/2. That should get me a super number. That's what? See if we can figure that out while I copy the code and bring it down here. -1 2/3.
I'm not sure.
Yeah, I'm looking at, I'm just back over here looking at the other slide over here. Let's, so we got, so -1 2/3 is, I gotta bring it over here and do it over here in this space. Let's go switch over to my machine. -1 2/3. 3 times 1 is 3 plus 2, that's equal to -5/3. That's how I did it. All right, multiplying that by -1/2. Whoops, it's behind you. Let me bring that up. Okay, what's that, Campbell?
That would be 5 over 6. 5, 6.
I agree with the bottom. I disagree with the top. What's the top number? Oh, no, wait, I'm sorry. No, you're right. You said it was 5?
Yes.
5, 6. Okay, good. 5, 6. Sweet. So that's what we're testing for. Let's go back over here, and we're looking for 5 over 6. We're looking for a +5 over a +6. That's what we're looking for. Okay, let's do a test run here. All right, let's do this. Let's pass in values so we can see what we're getting. Let's put parens around this and do a dot. Well, that's not. I think we're. Or no, wait. Let's do it and do a value here too, just so we can see. Because right now we're not getting the data down here to see what the problem is. Let's see what's going on there. Maybe I did a problem in my math too. I'm not sure. It expected a different number. 5, 6 is way different. It got to 1/3 is what it got. I have -1, 1 2/3. Is it possible? Yeah, you know what? I think our math is wrong, Campbell. I think our math is wrong in our assumption of how we do this. I think we have to do it my way. Right? The reason why is because look at this. If I have 1 2/3, right? Where you were saying, well, we just take this 1 and multiply it by the end result, and we just multiply 2/3, but it's not a 1, that's 3/3. Do you see what I'm saying? Which means we got to multiply that 1 has got to be a 3 times the top number and a 3 times, well, it's actually not times the bottom number here, because that's 3/3. This is 3/3 plus 2/3. It's not multiplied by it. Does that make sense?
Yeah.
Because it's plus. So what that means, our multiplication is wrong. So this is actually a great test. Let's just do all the tests to make sure only that one is failing, because we had a bunch failing before because of the test multiplication is the one that's dying. Okay, that's our problem. So that's great news. So let's go in there and fix that, our multiplication, our operator overload for multiplication. Here. All right, so what we need to do is we need to basically say, we need to make a call on SuperNumber 1, make improper like that, and assign it to a new SuperNumber one that's coming back from it, a SuperNumber that's coming back from it. We'll call it SN1. Like that. I want to do the same thing with SuperNumber 2. Okay. Now what's going to happen is my whole number is going to be 0, no matter what. Do you follow that?
Yes.
Oh, you do? Okay, cool. My numerator is going to still be numerator times numerator. My denominator is still be denominator. This times that. I'm gonna do this, and then I'm gonna say make fraction proper. So I still do this. I still got the signs. Make improper. So think about this, because I'm going to ask your help to write this. Here's what our goals are. Make the fraction the same, but I want whole number 0. How can I do that? Well, first of all, if it's a fraction, let's do this. If type equals number type dot decimal, then we could throw in a new exception, right? Where we say, hey, cannot make a decimal into a fraction. We could say that for now. Okay. So if you get down here, if we throw an exception, we're out of the method. So we get down here, we know we're in a fraction. So the goal is to make the fraction the same, but I want the whole number 0. Do you know how to do that? Can you do that on? If we just were going to do it, like if I was just going to give you a fraction on, and I just realized I have the white screen up again. Apologies for that, kids. Let's come back over here. Right there. Yeah, sorry, Code Blue is out there, says our whiteboard. Haven't been able to see anything in a few minutes now. Sorry about that whiteboard. Thanks for that. All right, so let's go over, we're going to the whiteboard now. So here we go. So if I have 4 and 1/4, like that, and I want to make this 0, but keep it be the same value. I want that to go to 0. Can you see visually, can you see what you need to do, Campbell, to do that?
No, I don't think so.
So can you think of a fraction that's a over b that's equal to 4 1/4?
Oh, yes. Yes, I can. It would be 17/4, right?
Yeah, so it's 17/4, but how did you get here? What did you do?
I multiplied the denominator times the whole number, and then I added that to the numerator.
Those two are multiplied. A little asterisk there for multiplication, and then they're added. The result is added to this guy.
Numerator.
And then this becomes 0, right? It's 0 plus 17/4, right?
Yes, yeah.
Okay. Back over to code. Sorry about that. Again, Code Blue. Thanks for the note on that. So back over here in the code, we want to make the fraction the same, but we want a whole number equal to 0. Can you do that?
Yes. Here, or on the line below this, right
Sure.
here. Ah, okay. What? Okay. So here we want to set what is the variable we're trying to set again? What
There's
is it called?
three key properties of SuperNumber that it has that we've been using
Whole
all over
number,
the place.
numerator, and
Right. And one more.
and the denominator.
Right. So
but-
you're going to work with those 3. But what?
How do I change the entire fraction? Because if
Surely David says, love the nickname, Code Blue. Code Bleu. Sorry, what'd you say? How do you change something?
I want to change the entire fraction.
Yeah.
Not just
So you're just going to set the individual pieces of it, is what you can do, right? So you have 3 pieces. Whole number, you set that to 0. You're going to set You've got numerator, you'll set it something. And you have denominator, which you're probably not going to change. All right?
Numerator is equal to numerator plus denominator times the whole number.
Got it. Good. I totally agree with that. You
And then
don't
also
need parens around there because of operator precedence.
I know, but
Okay.
I still want to, just so that it's easier for humans to know what it is.
Perfect. So I'm going to call that perfect. Let me show you one thing here, though. If we were to switch the order of these, switch that with that, would that still work?
No,
Why not?
because then we would be multiplying the denominator times the whole number, times 0.
Yeah.
And then
The
denominator.
order is important. I just realized make improper return something new. Yeah, I want to do that. I definitely want to return something new. So what we want to do here instead is we're going to create new variables here. So we're going to say new numerator. That's going to be an int, like that. We know the whole number is going to be that. I'm just going to come in here and say return a new super number. So pay attention because I want you to fill in the parameters here. What are the parameters we're going to pass in here?
The parameters we're going to pass in here are
Don't forget to hit Control Shift Space. What'd you say?
new numerator, right?
What's the first parameter? Hit Control Shift Space.
Yeah, sorry, whole number, and then new numerator, and then just denominator.
What's the whole number going to be?
0, so. So maybe just 0.
Code Blue is saying, I remember your test case with 5.6 also had 1.6 in the green part. Looks like we needed to change that. Okay, good. I agree with this so far. Good.
Numerator.
New numerator. Fine, I love it. What's this one?
Denominator.
I love it. That's totally it. That's a killer make improper, right? It doesn't change this number. It just gives us a new one. Now that we've done that, now we need to use SN1 and SN2. Everywhere in here, we were using SuperNumber 1 and SuperNumber 2.
Ooh, yeah.
Okay, so we're going to come over here. This is going to be SN2, and this one's going to be SN2, like that. Now I'm feeling way better about this. We figure out the sign up above. We make it improper. We do the multiplication. Let's go take a look at their test cases, because Code Blue was saying, yeah, here we go. There's the problem right there. It needs to be a 5/6. Thanks so much for that. That makes that look a lot nicer. And let's run the test case now. Passed. Let's run all our test cases.
Woo!
That's awesome, right? So now we know, even though we've been making changes, we know our addition still works. Looks like our multiplication is better now. It looks like it's better. Still, we need more test cases here, but definitely moving in the right direction. I'm kind of thinking, well, I don't know. Let's do this. I'm going to let you make a decision on this in terms of what you want to do. We can either add more test cases for multiplication, or we can try to use the regular expression tool we used to try to write some text, to create a class that will parse out numbers like 1 and 5/6 and turn them into super numbers ultimately from
Sorry,
text.
can you say that again?
Yeah, we can use the regular expression tool that we created to generate a class to parse in the text like 1 and 5/6 or something like that.
Okay, let's do it.
Do you want to do that, or do you want to add more test cases, what I was saying?
I think we should do the first.
Okay, so Campbell's starting up a Reg Explorer tool that we built, which, by the way, is pretty cool. It does this kind of a thing right here. Inside of here, here's a number.
Yes.
And do you mind? I kind of would like to take a stab at this first.
Okay.
I don't know if you mind that or not.
I don't.
But here's what I want to do. I want to find a number. What's wrong in here? I've got to tweak. What is the error? Quantifier XY following nothing. Ooh, there's a link out here from Code Blue. Let's take a look at this. Switch over to my machine. Regular expression. Yeah, I think I've played with this. Insert your regular expression here. Cool. Yes. Yeah, that's cool. All right, back over here to ours. So here's what I'm trying to do. Am I missing parens? I think I am. I'm missing a set of parens. Maybe there? No. What does this say? Your quantifier XY following nothing.
Can I try something really quickly? Dad, can I try something really quickly? Can I have
Yeah. Oh, I think do I have to put this in parens? Oh, sorry. Go ahead. I think I have to put the whole thing in parens is what I think I need to do.
Oops. No.
Yeah, I did that. No, yeah. I think I need a paren here and a paren here. There we go. That's what I think I need.
I wasn't missing 4 parens.
What'd you say?
Only missing 2.
Well, yeah, I also was missing parens at the start here as well. So this will match numbers right now. This is what we've got from before for matching numbers. So it gets that and it gets that.
Yeah, it gets negative and decimals.
But it's not going to get that. See what's happening? It's finding different pieces for this. And what I want to find instead is the whole thing. So I want to call this decimal like that, right there. And then what I want to do is add to that another piece, which I think we're going to call this whole number. Well, actually, I want it to be decimal or is what I want. I want it to be one of the two. So we're either going to match decimal, and I think I got to do this or something over here. And this is going to be whole number. What if I just did this for now? Dot star. What's wrong? Too many closing parens. That doesn't look or feel right. Hold on. So that's good. Can I do either or inside of brackets with parens? How do I do or in or two different options inside of? Let me switch back over here to regex. I don't remember how to do this, Campbell. Regex or two groups. That's essentially what I want to do. It's one from two groups. Fine. What's our answer? Look at the bottom right of regex 101. Yeah, it's not. I don't want a single character. I want one of two groups. Let's see what I can do here. Group construct. Yeah, I want to do this with a group inside of it, essentially. Well, this is character classes. One of two groups. Let's go back. I think I'm close over here. It's just the or inside is what it looks like it is. Okay, so what that means then is I do one more group piece here, the or symbol at the end, and then my new group here and my ending piece. Like that. All right, cool. Now, so now I'm working on whole number. So now, let's look what I'm matching for whole number. Do you know what that is?
Yes.
What is it?
It's the it's you can have more zero or more periods.
Right. So and what's the period represent?
It's the decimal point. Right?
Nope. Regular expression means something else. Because it's not matching periods, it's matching space and 1 and over 5.
It's just anything, right? It's any. I want to say digit, but that's not true. It's like any digit or any word, any letter, any character.
Any character. That's right. That's exactly right. Good job. Okay, so I want to get. We need to get something like this, but without the decimal point. Really kind of, I think it's to there, if I'm getting it right. Looks like it's not. Looks like I failed that. There it is right there. I don't need this. This just means dot decimal points. We don't need that. But we just need this. And so now, it's still not matching it yet. Full number. I don't think I need these parens here. And then what I want to do is space, character, followed by another digit. And that digit, I'm going to put that in parens, and we're going to give that a name. This is going to be my numerator. Followed by so I'm trying to figure out why the whole number doesn't match this yet. Is it because I need to go all the way to the end? Let's try going all the way to the end and starting all the way at the beginning here as well. So there's no match here yet. That's, I think, better. So we've got a digit, one or more digits, that's my numerator. That ends there. Okay, and then followed by an optional white space, so 0 or 1 of these, so that's a question mark as I recall, followed by the div symbol, which is /, and this really says, I forgot I was back on a decent internet connection. I'm still watching blurry drones. Oh, okay. Well, good, I'm glad you're back. Now what's interesting here is I'm not finding. Oh, I'm not finding this. I'm not finding it yet because I don't have the second number in here. Let's go grab the second number. I think it's going to go from there to there. Yeah, that feels right. And then this is going to be my denominator. And then we just got to figure out how to get this symbol in here. Let's see if this is matching it. That does match it. Okay. So optional white space there, optional white space there. At this point, I feel like I should get a match. Decimal, or I think all of this needs to be in parens. Would that be it? Still not finding it, Campbell. All right, let me copy this to the clipboard. I'm gonna try and look at smaller bits of what we want to do. I'm going to, with that copy to the clipboard, I just want to try and match this right here. Why can't I match that? is my question. So here is good, it gets those numbers. There it gets the -1. Does it get the space too? Hard to tell. It does not get to here. We don't have two spaces here, do we? Just one. So why is it not finding that? I don't know. Do you have any ideas, Kimball?
No.
Don't you think you're accounting for the /? Yeah, I don't have that yet in here. It's kind of weird to me that it is not finding the next one here. In other words, I can find, if I take this out from here to here, I think, from there to there, we find that -1, no problem. I say, okay, fine, I want to keep going. Like if I was just typing in here 1/5, it finds it, which means I should be able to take this 1 and replace it with that, and it should still find it, right? So there it is here. I'm taking that 1, I'm pasting in this. Oh, I see it. There's my problem.
Oh.
Okay, so there's my numerator. I didn't have that because that's what's needed to name it. Okay, so now I don't need the /5 anymore over here. Now I just need the / and then denominator. Okay, now my whole number. Why is my whole number so big in this? Is it because I'm missing something there? There it is. Wow. Okay, that took a while figuring out. So now, see what's going on?
Mm-hmm.
Tell me.
So we're checking to see first for the -1, which we already had, and then we are looking for the number after that, and we're making sure that it's not separated by a / between that and the next number, and then we find the next number that is after that.
And we're getting these 3 pieces.
Yes.
All right, good. So that is, we're going to say that is, I want to look for white space in front of it. And I think I want to look for white space at the end as well.
Yes.
Which means in order to find this, well, we've got to do that kind of thing. Now, so that's, I'm going to delete the white space for a second here and here. I'm going to take this piece that works now. I'm going to go back over to this piece here. So I was basically trying to make that work. So, and I think that's it. So let's try doing that. It says, no, I don't see you, I'm not working. Because I got a space there maybe, and a space there. Okay, there. So now, check it out. If we type in 1 1/5, we get that. See what we're getting, Campbell? Look at that.
Yes.
Now let's try typing in 2/3. Well, I don't know, try typing in 0.12. Try typing that in.
It works. And it
finds a decimal. Now type in 2/3. I think it's not going to find 2/3.
Yeah.
It doesn't find that because whole number, this piece, is required.
Yeah, we have to make it optional.
Yeah, so I'm going to take from here to this space, I'll put some parens there, I'll insert it, and then I'll put a question mark there. And now look at that, numerator and denominator we found. So let's go back and test the others, make sure we still find the others.
Okay, so that works. Yep.
What about -5/7?
No.
That means my numerator needs an optional sign on it. See that right there?
Yes.
That's the bit that gives us the sign. That means our numerator can take an optional, whoops, sorry, not there, here, right there. And now it found -5/7. See it?
Yes.
All right, good. That's
Now
awesome.
what about a negative decimal? Oh, wait, no, we
Zero.
should get that.
Should be good because we've already had the decimal part working. All right, good. So now this is going to be, so this is just going to take a single string that's the number. It's not going to be able to grab it out of a sentence right now, but it's not bad, right?
Yes.
We can just give it, if we have a text box for entering this value, we can enter a lot of different values and we can turn it into a number and work with it. Does that make sense what I'm saying? Okay. All right, so let's do this. Let's give this a name. We're going to call this our decimal fractionator. Fractionator?
Yes.
Or a decimator? Our fractional decimator?
I think I like fractionator the best.
You like fractional better?
Fractionator.
Just fractionator all by itself? Or?
No, sorry, decimal fraction.
Okay, there it is right there. The text to test is going to be like that, 1/1/3. Okay? All right, let's copy that.
With the regex helper.
I think so, because we haven't used this yet. So we're going to copy that. Good. Good luck. I love that the code generator. Let's go back to our other project.
Okay.
Don't lose what's on the clipboard because you stopped the other project. Remember you stopped it from running?
Yes.
It's no longer there.
Yes.
So it's incredibly important. We want to go stick it out, I think somewhere in your SuperNumber. Somewhere in that
No,
space.
but we have the clipboard history, so it's fine.
All right, there we go. We pasted it in. Let's start moving stuff to new files. Move that type to file. Come back and move regex helper to its own file. Let's go bring in system text regular expressions. Should be all we need there. I think we're good there. Next, we need, I think for good test, how much time do we have? Oh, we have almost no time. Maybe we just stop there. Do you want to just do that, Campbell?
Yeah.
We say, we'll check in the code. We created the multiplication override. We added new test cases. So yeah, operation overload for multiplication, we did that. And we added our regular expression parser to get us a number or a decimal from text, either a fraction or a decimal. And that's it. I'm going to, thanks everybody for joining us. We'll be back almost a week from now with continuing this.
Yeah, and a little less.
Code Blue, thanks so much
On Friday.
for helping out there and giving a suggestion on regex101.com. Appreciate that. I'm going to get a raid going. And while Campbell types that in,
Yes.
gets that going. Do you have any questions, Campbell? Sounds like you had something you wanted to say.
No, I don't.
Send you over to Lana Lex.
No, I don't. I don't.
Have a good day, everybody. Have a good rest of your weekend.